Jai Hind everybody. Today we would be discussing the remaining three components of the blockchain system. In previous videos, we have seen what are the different components of the blockchain system. First was the node. In the node, we have seen that we have two types of nodes, that is the full node and the partial nodes. Okay, full nodes keeps all the transaction histories into it, and the partial node keeps only the block header information, for which they verify that particular block as a unique, and then we can do the transactions. Ledgers were basically the distributed databases or the local copies of the database on each and every node. Okay, and I think node were physical devices which we can connect. These can be your mobiles, this can be your laptops, this can be your desktops. Any physical device which is being connected with the internet connection is called as the node. And the database which is on each and every node was called as distributed ledger, or the ledger which keeps the entry of all the transactions from the day one which is being taking place in that particular blockchain environment. Next was the wallet. Wallet was a software program which generated a unique wallet ID along with your private key, public key combination, it along with what all coins have been generated or created by that particular wallet, and the transaction history along with the balance in that particular wallet. Okay, so these were some of the things. This is wallet ID. Okay, the unique number which is being given to each and every wallet. So these were some of the things in this particular. Basically, wallet is a software program which generates all these things when it is run on any of that particular node. Okay. Then it was nonce. So nonce were random numbers which were generated at particular point of time, which gives uniqueness to that particular records of the blockchain. Then we have considered the hash function. The hash key was the key which was having a fixed length output for variable inputs. And the algorithm which we have used for this particular was secure hash algorithm 256. If a single bit was changed, a single alphabet was changed, there was a massive change in that particular message, and that was called as avalanche effect. We have discussed all these things in our previous video. Okay, so some of more things about this particular hashing, which we have to see how this particular hash function is using the previous hash and how do we generate those particular things. We would be discussing some more things of the hashing in this video, along with what are different mining techniques or what are different miners who can be the winner in that particular blockchain, and what do we mean by consensus protocol. So coming to the hash, we have seen that hash was usually a unique alphanumeric 256-bit or 64 characters which was uniquely generated, and we use that to identify that particular block uniquely. So the first use is we have a timestamp of a digital document. For the first, it was used in 1991 by Harbour and Stomata, and they used it for timestamping a digital document. There was a document, and if we want to know who has updated that particular document, so a current timestamp when that particular document was updated and saved was attached with that particular document to uniquely identify who was the user who has updated that particular document and at what particular point of time. So timestamp is the current time, and this time is usually in your hours, minutes, seconds, and even the milliseconds, so that we can uniquely identify it as we can uniquely identify with the nonce, which was one of the component of the blockchain. So similarly, we have the timestamp attached to this particular digital document, and which was firstly used in 1991, and it was used for cryptography, sending messages, for securely sending those particular messages. So a sequence of timestamps, TS1, TS2, T stands for time and S stands for stamp. So TS denoting when that particular document was created, when it was edited, and who all did that particular thing. Whenever a client accesses this document, it creates a block consisting two sequence. One is the number of the access. Okay. First thing is number of access. Second is client ID. Third is timestamp. Fourth is hash value of the previous request. Okay. And the entire thing is hashed and connected together to the previous block. So here all these four things we can see in this particular diagram. See, when we are creating first hash, we have this particular access ID as 0 because that was the first block which we are, or the first hash which we are creating. Then this is the client. The second was client ID. So it is the client which is doing it at what particular timestamp, and this is the previous hash value. As we don't have any previous hash key value at this particular point of time, we usually have some constant which is being decided by the group of the peoples. Okay. So this first times hash H0 is usually a constant number because we usually have that particular in the alphanumeric form. So we can have a unique number whenever we start encrypting or when we start cryptographically securing that particular data, we start hashing it by H0. And when all these taken together and the hash function which is being used here is SHA. So secured hash algorithm is used, and then if I'm using 256, it would generate a code H1 of 256 bits. This H1 is unique. This H0 was unique. This H1 uniquely identifies that transaction 0, the number of access 0, was done by client C1 at timestamp TS1. Okay. Now we are using this particular previously generated hash into this particular, the next hash to be generated. This is the first access. Here it was 0. So we are sequentially increasing that particular value. Then the client can be different client, or you can have the same client also. Here we have taken the different client. So you can have a client C2. Obviously the timestamp would change because we are considering into milliseconds also. So even if not the hours, minutes and second changes, but the millisecond changes if you are frequently doing that particular hash keys. So you have a different timestamp, and we are using the previous hash values as a part of whole message, which has to be again hashed by using SHA algorithm. And again we would be generating a 256 bit new hash which would uniquely identify that the number of access is 1, which is done by client C2 at a timestamp TS2 using a previous hash, that is H1. Here similarly, this H2 is being used to generate H3, the new hash, and this H3 is being used to generate a new hash which has an access number of 3. The client is C4. The timestamp is TS4. Obviously, whenever we are doing this particular transaction, the timestamps are varying, and it should surely vary because in cryptography, we only use this timestamp as a unique identification number. But in blockchain, we use timestamp as well as a nonce to create that particular uniqueness. So here the timestamp is being used in the hash. So it is utilized in the hash. So hash becomes one of the unique number, and the second is the nonce, which is a unique number. So two unique numbers which identifies a block. One is the hash key which we are generating, and second is the nonce which we have it. So here again we are having this H3, the previous hash, and we are generating a new hash by SHA algorithm, and it is again 256 bit. I think from this diagram it is very clear that these particular arrows which I am drawing shows that there is a relationship between the previous hash value and the current hash values. We are taking the previous hash values. This was the original one, and this is the one which was created. Then I am using H1 as an input to second hash value, and then I am generating H2. Then H2 is used as an input to H2 to generate H3. One of the input, not only that input, one of the input of this particular chain. So in this particular thing, we can conclude here that we are having a hash chain. Chaining of hash, we are calling the previous is used to denote the next. So this chain, I think this chain is clear to everybody. So this chain is called as the hash chain. This hash chain helps us to convert, this hash chain is being converted to a blockchain, because in blockchain also we would be using this hash values from the previous block to the next block to create a new block. So this blockchain is derived from this hash chaining technique. So this the blockchain basically uses the concept of hash chaining technique, which is being shown in this particular diagram with the purple color arrows. Okay. So these are unique keys which uniquely identifies each and every messages. So for generating, we only don't have only one single function. See here we are having, wholesomely I've used only one hash function. That was SHA256, here also, here also, here also, and here also. These are four times I have used the same hash function. It's not compulsory that we use the same hash function. We can have heterogeneous hash functions which we can use it. So while we are having this particular thing into the blockchain, this was again first of all used in cryptography, and it was used in 1979 by Rolf Markl. He has given a tree which was known as hash tree or a Markl tree. Okay, so what does this tree is having? See, we will first consider this particular diagram, and then we will come to all the descriptions of this particular diagram. See, the leaf node, what we are having in the leaf node or the child node. What is the basic thing we are having in this particular leaf node? In the leaf node, I have, or in the child node, what do we have? In the child node, we have only the documents which are the content, which are the basic contents which we want to send from one user to another. This is in terms of, again, this was implemented in terms of cryptography. In blockchain, we are using different subjects, and we are having that heterogeneous environment or heterogeneous system in this particular thing. So one is cryptography, one is database, and then we will discussing network also. So all these three things along with some concepts of the blockchain combines and gives you something different, and that is more secure. So this was used in cryptography. So cryptography is sending a data securely from one place to another place. So these documents, see these documents D1, D2, D3, D4. Assume I have 15 hash functions, 15 different hash functions. Okay. And I can use same hash function to hash all these 4 documents, or I can use different hash functions to hash this particular document. We can have heterogeneous hashing, or we can have an homogeneous hashing function. For homogeneous, we can have same hashing function like I have used in the last example, like SHA256 is used for all of them, or we can have different. So if I'm assuming that to the left child, I would be using a hash function H1, and for the right child, I would be using different hash functions. Anything. But here I am taking in the chronological order. So D1 is being hashed using a function H1, hash function H1, and it generated a unique code that is H00. D2 is being hashed using H2 hash function and it has generated a unique code H01. Similarly, D3 document is hashed again by H1 using H1 as a algorithm and generated code is H10. Obviously, these documents are two different things. So, it would generate a new code. Then, even if you are using the same, but if the contents are different, it would generate a new code. Then the D4, that fourth document, it is being hashed by H3 function and we have generated a code H11. Okay. Now, see, here I have H00, H11, H10, H1, again H11. So, what in the second level, what we are doing, I have to hash these two functions. Okay, this is the second level. When we are considering this in the form of the tree, this is the root. This is the first child node. This is the second level. So, here all these are written as L2 cache. Why L2 cache? Because second level. If I again the third level, it would have L3 hash. Okay. So, that would be the third level in the tree. So, these as the level differs, the hash, the number which I am giving to that particular hash would differ. So, here L2 hash, the L2 hash contains what value? H00. So, here I am combining H00 and H01. That means this hash function, assume this hash function is H8. It takes two inputs. One input is H00 and H01. We are not adding those values. Keep this in mind. It is taking two input values as we were taking here 4 input values. So, we are taking 2 input values. Then we are hashing it by H8 hash function and generating a value of H0. Here again we are taking two inputs H10 and H11, combining it, running it with H12 as a hash function and then generating H1. Now again here two inputs to this particular hash function. I am using H6 as the hash function which I am utilizing it. So in each and every node we are hashing. So this is hash once, again hashed second time and again hashed third time. So a simple document D1 was hashed 3 times along with D2. It's generating a new value. So it's a value which is going up in the hierarchy. So it is moving up. It's bottom up approach which we are using it. So each and every leaf node has the hashed data block. Data block which has to be hashed is there in the leaf node. And each and every non-leaf node has all those particular labels or all those particular cryptographic hash labels which we require to generate that particular hash values using different hash functions. I think this is clear. So, Markley tree is a tree in which we are rehashing and rehashing. Assume this, see, here we have a level of, here I am using 7. If I take it from here 1, 2 and 3 levels. So, 2 raised to power in the tree, how many nodes do we have? 2 raised to power 3 minus 1, that is 8 minus 1 is 7. See, 1, 2, 3, 4, 5, 6 and 7. 7 times we are hashing these particular 4 documents. So, how can anyone temper that particular data? How anyone can temper that particular data? That is the most difficult thing, but it's not impossible. It's the most difficult thing. It's most infeasible thing, but it is not impossible. Okay. So, anyone who is having high processing speed, anyone who is having high computing power can track this particular hierarchy and do it. If that particular person or the listener or the hacker knows that you are using these 15 functions, so he can do a brute force attack. Brute force is hit and trial attack and then search for that particular text. So, what are the uses of that particular thing? It was, first of all, it was designed in 1979. Then it was used in 1992 along for time stamping. Here it was used only for time stamping. Okay. Then it was used for time stamping and verifying the digital documents, which improves the efficiency while we are distributing that particular document from one place to another or connecting it from one document to another document. Other use is peer-to-peer network. The data blocks received are undamaged and unaltered. These are the basic. Anyone cannot damage it, anyone cannot change it. Damaged is you cannot delete something from it. Unaltered is tamper-proof. You cannot change any of the data. Anything cannot be done to that particular text unless and until there are very, very, very high processing power required systems, because as the level of the tree increases, because we know when we have this particular tree of nth level, the number of hash functions would be this. So as the height of the tree increases, the number of the hash function increases. So this particular technique was basically used in blockchain in the Bitcoin implementation of the data, which shared information are unaltered and no one can lie about that particular transaction. If I'm doing that particular transaction, I cannot deny it. I'm sending money to one of my friend, that friend cannot deny it, because the value which is being transferred is this hash value, and these hash values cannot be tempered. This cannot be change those particular text which is there in that particular documents. So next component, I think hash values are clear. How we generate those particular unique hash values, that is 64 characters or 256 bits. The next component comes is the mining. It is a mechanism where nodes are called as the miners in the terms of Bitcoin and are called as forgers in the terms of Ethereum. These are two cryptocurrency, well-known cryptocurrencies, and in this cryptocurrency world, we have two words for the same. Miners is being used in the Bitcoin and forgers is being used in the Ethereum. What do these particular miners and the forgers do? They validate the new transaction and add them to that particular blockchain distributed ledger or in that particular blockchain. So miners and the forgers, they usually compete to solve this particular problem, and these particular problems need to be cryptographic hash algorithm, and these particular cryptographic hash algorithms are very, very, very secure hash algorithms. Now this mining comprises of hashing block and then introducing a nonce to the hashing function and running that particular hash value all over again. So what we have is, I have a hash with a nonce and then again using a hash function, then generating a new value. So here is where that particular complexity comes into picture. So how do we do this particular mining? We would be discussing in next video. Thank you for this.